Alright, so day 22, I didn't really have time to do like a full day of doing it, but we can go to the solution. It was a pretty simple day, and I used Kotlin for day 22. So I would say that most of this description is kind of useless. Um, it was just a matter of finding where the algorithm is given to compute the like each number that it wants you to compute, and then just simulate it how many times it says to simulate. So that was kind of it for part one, and part two was kind of similar. You just had to keep track of the results for each iteration from part one. So just a matter of adding a hash map basically. So let's go through the problem description. So we are in a, yeah, in a jungle. We have to find some hiding spots to trade for bananas or something, and we get to a like market, and the prices there are pseudo random. So they feel random, but they're actually based on a small algorithm with a seed. So the idea is we have a function that takes in a seed and gives us a seemingly random number. So luckily enough, we have the list of, let's say, the initial seeds, and this is funny because for part two it's a different one in the examples, and I thought that they are the same because, just looking quickly over them, it was 1 2 3. Okay, it's the same as part one, but it was actually different, and it took me like almost 1 hour to see that and try to debug something that was actually working. But yeah, so the algorithm of generating the random number, it's given here, and it's just multiplying with 64, then XORing with the seed, and then modulo by 1 to the power of 24 or something. It's given, yeah, here, 1 to the power of 24 minus 1 or something like that. No, 2 to the power of 24, yeah. Then we divide the number by 32, and we again XOR with the result from first step, and then we multiply with 2024 and multiply with the result from the second step, and we also have to prune the secret number, so modulo by this amount. So yeah, and in the end we have to simulate this step for 2000 steps and sum up all the numbers. And I'll say that in Kotlin this felt really easy to do. Like the PRNG algorithm, I mean, it was pretty straightforward. It was, again, see, just shift left 6 means multiplying with 64, basically. Then we shift right with 5, so that's dividing by 32, and shift left with 11 is 2 to the power of 11 is 2024. Yeah, I was like, okay, yeah, 10 is 1024, so double that is plus 1. And as I also noticed, the mask was 2 to the power of 24 minus 1. Right. So again, we just do the XOR between the seed and that result of the first step, and so on. And at the end we get a seemingly random number. So for part one, and initially I did let's say the implementation with just the for loop and the sum variable, and it looked more like Java, let's say, like the code looked more like Java. But I actually found this cool iter tools, let's call them, like the one in Rust, to be able to write it in a single line, sort of. I mean, it's just for formatting on multiple lines, but it's a single instruction that just iterates all the steps, and then it runs the algorithm on itself. So yeah, it's kind of cool in Kotlin. That's really like I was expecting it to be more like Java, like uglier, let's say, the more corporate version, but it's actually more like Rust, like a combination between Java and Rust. Now, well, yeah, if you just use this itertools function, it looks like a bit of Rust, and yeah, that's actually pretty nice. So for part one, all we had to do was just apply the algorithm on the seed and get the result for 2000 times. And then for part two, this was a bit more tricky, but still kind of simple. We notice, or at least the prices are not these random numbers, but they are just the last digit of the random numbers. So if you think about it, these last digits, I mean, there are so many of them, so they are gonna repeat, and we are interested in finding a set of 4 consecutive changes such that the price is like the best one for us, say. And the best one for us should be the highest one, because that's when we sell. It's like we are trying to scam the I think they are monkeys. Anyway, so we have the list of last digits that we can generate from our random numbers, right, at each step, and we compute the diff between them. So you can see that between the first one and the second number is a diff of -3. It's 3 and 0. And then between 0 and 6 is a diff of 6, and so on. And why do we want the list of diffs from the last 4 numbers? Well, because it's like because of this story, right? We need to find the most common substring of 4 diffs in all of the sequences. So yeah, if you go through the description, that's what it's gonna say. It's gonna be like, okay, what's the most common sequence of 4 differences that you can find? And well, ideally, I mean, the question is, what is the most bananas you can get, right? And here is the funny part. I was using 10, 110, and 100 here, and the answer was 24. So I was like, oh, it's a one off by 1 error. Why am I wrong? But I didn't see that it's actually different. So that was quite funny here, and I wasted like at least 30 minutes on that until I saw, oh wait, it's 1, 2, 3. Oops. Anyway, so yeah, right, we get these differences, and based on these differences, if we get, let's say, so if we imagine we create a hash map that as a key has this list of differences, and as a value it has the price, right? Imagine we do this thing for each number, for each seed. So we have for each seed a hash map that goes from a list of 4 differences, consecutive differences, to the price it represents. So if we combine all of these hash maps by adding the values, right, we would sum up all the values. The keys would remain the same. So if we search for the max value now, we just get the max value. So that's all we have to do. Just keep track of the diffs, put them in a hash map, and add up all of these hash maps. So again, for part 2, initially the solution was much simpler. It was with for loops and all of that. But I thought, well, if I did it for part 1, that will it work? Like, I wanted to test out how easy it is to do these folds and maps and iter functions in Kotlin. So why not? And it's actually, yeah, it's pretty straightforward to use these functions. So for instance, here we iterate over all the numbers, and I used a fold. So basically a fold is similar to a for loop where we have an initial value, which is the map that I talked about, right? Which I called prices for some reason. It's like the map from the differences to the price, and then we get the number from the for loop, right? So initially that list of differences is going to be all zeros, and we need to initialize it first, because let's say the first four numbers, they don't really matter because you don't have a full list of differences. So you just have to initialize it with four numbers, and then we can actually go. That's why I have this j is greater or equal to 4. So yeah, the idea is we take the last digit from our seed, we then just generate the random number, and each time we take just the last digit. So here you can see we save the difference between the current last digit and the last one, and we also iterate it. And here we just add our price to the prices hash map. So we just do a plus. As I said, we just sum up the values. And yeah, we needed this visited map just so we don't add, because if you think about it, as I said, there are a limited number of last digits. It's like from 0 to 9, so they are going to repeat themselves. So we don't want to add it multiple times. We want to add only the first occurrence, right? And yeah, in the end we are going to be left with a hash map that has this sum. So we just did the maximum value. And yeah, I was actually quite impressed by how easy it was to write a Rust-like version. It was even easier than Rust itself. So, I would say that if you want a less annoying version of Rust without the barrel checker, and I mean, this has automatic memory management via, JVM, so you don't even need to worry about pointers and references. I mean, Kotlin is a good choice, I'd say. So yeah, I mean, we would have to test it more, but just by first impression, like, it has folds, it has generating sequences, I mean, it's lambda functions, it's like pretty cool. So yeah, and for the result I also used long. Not sure if it was required, but I thought that, well, yeah. And I made like, well, I downloaded the input for day 23. It's humongous. Oh my god. I mean, I want to try it. Wait, what? Try it out. I'm curious about probably in Neem, hopefully, if it's working. And yeah, I mean, it also just oh, I have to change its name, but yeah, and as I said, it was pretty interesting to use Kotlin. It was also quite fun experience of writing it like this with folds. So yeah, hopefully that was interesting, and we'll see in the next one.